Hello everybody. This is Ned from pre-sales department. I'm responsible for North America and South America technical support. So welcome to join, and we are going to talk about today is some basic knowledge of inverter and PV system, aiming at colleagues who are new to solar field, and also help you better understand the three trainings below. And we will open up the floor for questions about 5 minutes at the end, but feel free to post any questions that you have during the introduction. Today's topic, we are covering inverter category, where some common used inverters on the market, and then is parameters of PV panels and inverter, and then is some definition of parameters, very detailed. We will quickly go through that. And at last, we will introduce the string design for inverter, like how many panels should we connect in one string, and how to select battery in the energy storage system. This slide, we have three types grid-tied inverter on market. You may also notice there has off-grid inverter on market due to it works individually and no impact on grid. So we are not covering that today. And first is the macro inverter. Installing on PV panel's backside, it has a DC connector directly connecting with the PV modules connector, as you can see here by the MC4 connector. This is a macro inverter. Then is a string inverter. This is also what our company keeps making efforts on since the year 2011. So it's a string inverter. And the last one is central inverter, often used in big C&I and utility solar projects. Nowadays, central inverters often combines upgrade medium voltage transformer on same skid design. This slide, we will introduce the macro inverter. The power range is about 0.25 to 3 kilowatt, normally it's one macro inverter connect only one panels or two, but we also see the maximum panels macro inverter can connect on market now up to 6 or 8. 8 is also developing. And as you can see here, the DC voltage of macro inverter is 60 ampere. So it's safe for compared to other two inverters, but the cost is high. And as you can see, the manufacturers on market like Enphase and APS, Homice, etc. I'd like to introduce in the North American market, the Enphase is also a leading macro inverter manufacturer. It takes about 80% macro inverter market share. So this is about the macro inverter. And then is a string inverter. The power range covers very large, from 3 kilowatt to 320 kilowatt. The DC voltage from 600 to 1.5 kV. And for single phase inverter, the rated DC maximum DC input voltage is about 600. And for three-phase inverter, normally it's about 1.1 kilowatt. And for utility projects inverter, it's about 1.5 kV. So in the IEC standard and the US safe code, we have the regulations to we have a requirement that only below DC 1.5 1.5 kV and AC or AC 1000 volt voltage only this range falls into the low voltage range. If your voltage higher than that will be a medium voltage. So it will have different regulations and safety code for that. And the cost is the middle, is far lower than the macro inverter, but slightly higher than central inverter. Manufacturers like us and Huawei, a lot of manufacturers working on that. Last one is central inverter, only used in big C&I projects and large-scale solar projects. The power range is about 500 to 3,000 kilowatt. And as you can see, the DC voltage is also very high, but it does not have enough MPPT for if you have too much shading areas. But the cost is very low. As you can see, the picture here is a Sungrow central inverter. At the left part is the central inverter. On the right side, and you can see is a medium voltage transformer for upgrade. And here, through here, connecting the AC output by the AC conduit will directly connect to the medium voltage transformer. And this slide, I would like to share a common misunderstanding most newcomers may have. Does these three inverters still work when there is an outage from grid? The answer is no, because when the grid has an outage error or the grid failure, if the inverter keeps energize the grid, like here the overhead line, if there is a worker still doing the maintenance or the operation on the line, it will be cause electrical shock. So almost every country will have the local regulations based on IEC. So all the inverter on market must have the anti-islanding protection. If there is a grid outage, the inverter must cease to energize the distribution line in 2 seconds. So this is a must for the grid-tied inverter. And next slide, I'd like to introduce, if you want your PV system keeps working during an outage, then we will introduce two types of storage inverter and energy storage system. A little different from the grid-tied inverter. As you can see here, it will have a battery for the inverter. And if there is an outage, the internal circuit will have an internal switch to switch the UPS load. And when the grid outage, the PV panels can keep working and the battery keeps working to energize the UPS load. We can see the internal diagram here. The solar is which is a DC power for the inverter, and he has a DC-DC module to convert the DC energy and to the before the DC energy converting to AC, and the battery will still have a DC source to convert to AC to the DC voltage to supply our load. So this is an energy storage system. And quite different from that, we also have an AC coupled solution. If a user has already have existed grid-tied inverter and they still want to use the PV systems solar power when there's outage, they can add an AC coupled inverter and a battery on their system. It also can works like the hybrid inverter. But when the grid system goes down, the grid-tied inverter also goes down, but the AC coupled inverter can still work to energize the off-grid load. Next section, we will introduce the PV panels parameter and the inverter parameters. Mainly focus on the electrical parameters. And when we selecting a PV panel for the system, as you can see here, we can find a data sheet. So this slide, I'm going to highlight 2 points. First, you can see the 4 parameters here is very important. It's related to inverter string design. Also, you need to aware that this data was captured at the SDC condition, and the temperature, the radiation, and the air mass. So if air temperature lower, the output voltage of a module will be higher, and the output current will be less. So this is the PV module's character. And then it's the IV curve and the PV curve here. As you can see, and the same radiation conditions, there can be a specific point that we can achieve the maximum power point. PV panels cannot always operate at their maximum power point, and this is how the inverter MPPT technology helps to work it out. So, for example, at radiation 200 here, you can see, and if your inverter set the voltage at 10 volt, and the output power will be limited at 10 multiply about 2.5 ampere. So the power will be 25. But if your MPPT technology set the voltage at here, and you will achieve a maximum power point output. Well, based on the understanding of the panel's rating, it's easy to get the inverters. I would like to introduce first is a maximum PV array power. It's a DC over DC AC over rating capacity, and then it's a max DC voltage is to tell you that how many panels that you can connect in one string. For example, it's related to voltage of open circuit of the PV panel. And then is the MPPT range is related to VM maximum point of a PV panel, the voltage of a maximum power point. Then is rated DC voltage, and around this DC voltage, you will achieve the highest efficiency of converting efficiency of inverter. And then is a start voltage, only the connecting voltage larger than 100 volt. This machine will enter the standby mode. Then is the input current like 16 ampere. It's related to the PV panels IMMP, and then is like a short circuit and MPPT. For example, these 2 strings it's about 2 combines together for 1 MPPT. And then is AC output. I'd like to introduce the efficiency. You can see the efficiency on the data sheet of inverter. The maximum efficiency is in under any conditions that the inverter can achieve. So that efficiency you can label on the machine. And then is Euro efficiency. It takes local weather conditions into consideration. You can see the formula here, and and the different working conditions for the inverter will take a different weight. Also, we have the California Energy Commission for the efficiency. This is about the inverters parameter. Next slide is the this 3 photo delivers the message that when the PV panels series connected, first is the voltage will be combined together. As you can see here, these 3 panels are all 6 volt, for example. Then the combined voltage is 18. And as you can see here, 5 plus 7 and plus 9, the series connected voltage is about 21. But if you series connected the panel, the current will be limited at the lowest panel's power generation. For example, like here, the series connected current is only 1 ampere for the lowest ampere. For the lowest power generation is 1. And but you when you plus the possible power here, first is 3 watt, and then is 21 watt, and the third one is 45 watt. So when they plus together, it's actually it can offer 69 watt. So so when you series connected different panels for power generation panels together, the power will be lost and be limited. So how do we solve this problem? And on the panel side, and the PV panel side, the internal circuit, the PV panel will have the bypass diode design. If there is a shading on these panels and these cells, they cannot provide power generation, then this part will be bypassed. The diode will be activated here, so we can ignore the lower current generation on this side. And on inverter side, normally it works like here to achieve the maximum power point. But when there is a partial discharging, as you can see here, the current is decreasing sharply, and then the inverter will adjust the voltage and the current to find a new maximum power point. This is also why multi-MPPT technology can help you to achieve a better power yield. Next part is the factors in impact on PV system. As we all know, the PV panels offers the power generation, and the inverters help to convert. But when the temperatures goes really high on your PV on your solar plant, the output power can be decreased. As you can see, the red line here, normally it's the 25 degrees Celsius. If the temperature goes high, the voltage will goes down, and the power also goes down, but the current will slightly increasing. And then the big factors for the PV system is the power light density. If light density goes down, you should remember that the open circuit voltage decrease very slightly. Not big impact for the voltage, but a very huge impact on the current. So if there is a shading there is shading on the PV panel, the current of a PV panel will PV panel's output current will decrease sharply. In the third section is some parameters definition. I'm not going to read it one by one, but so you can check it after this training. And the first is LCOE. I would like to share, noted that the total system cost, including the operation and maintenance cost, and the total system power generation is during life cycle, the total power generation for your power plant. And the LCOE of solar is about 3 to 4 cents USD in nowadays. And next slide is STC. These parameters we have introduced on the PV panel section. This is the temperature coefficient and NMOT. This is battery parameters is capacity. 100 ampere means the discharge with 1 ampere current, it can work for about 100 hours. And if your battery rated 100 ampere and it has also rated voltage for that, if you multiply these two values together, you will get the total capacity of your battery. And you can see here it's about 4.8 kilowatt hour of electricity for this battery. The abbreviations of SOC is actually the battery you have remaining power in your have the remaining power in your battery. If the SOC is 100%, that is fully charged. Then is DOD, it's a depth of discharge, and you can see the diagram here. The DOD is 70%, and at SOC, the remaining 70% electricity in your battery. Then is the charge and discharge ratio. You often see charging at 1C speed. 1C means your battery is labeled 100 ampere hour. If 1C, that the charging or discharging current is 100 ampere. If it is labeled 0.5C, that will be 50 ampere. Then is the BMS for the battery monitoring system to monitoring the current, voltage, and the temperature, a lot of parameters of battery to help inverter better control the system to discharge or charge or discharge. Our last section, we will introduce the string connection, that how many panels should be connect. Before we talk about the calculation, I would like to share a little difference between string inverter and a central inverter. For example, the very big difference is the startup voltage. For example, it's for string it's about 200, and for central it's very large. And at the morning and before evening, the string inverter will have a very have longer operation time than central inverter because it has lower startup voltage. And when the PV strings voltage hits the threshold, it does not mean that it will power generation immediately. It will make the machine enter the standby mode, and will check other data like the power is enough and the voltage hit the 200, and all the protections and all the lines connection works okay, and then we'll enter the power generation mode. And as you can see, string inverter also have a MPPT range larger than central, and more MPPT control strings. Next is a calculator of the number of strings. First, we have a standard formula here and here. First formula here is for the inverter. for the outer circuit voltage, if you connect the PV panel on the inverter and the inverter does not work, and you can achieve the open circuit voltage here, this is the value. And for example, the three-phase inverter we are commonly using, the VDC max for inverter is about 1,100 volt. But you can use this data to make the calculation. And but most inverter manufacturers set the protection line is 100 volt. If the screen voltage is larger than 100 volt, the inverter will shut down and generate an alarm to tell you that there is a DC bus over voltage. So when you make the design, you should take notice that. Then is the PV panels open circuit voltage and the temperature, PV panels temperature coefficient factor. You should take this into account, and then you can you can get a range of the maximum pieces panels you can connect. The second formula is for the MPPT working range. You should make sure that the panels you are connecting will have enough voltage to support to fall into the MPPT range. So this is a second formula you should take. After that, you will get to range. You can then you can decide how many panels you can you connect in one string. And you can also follow these 4 steps in tropical area. But normally, if you want to quick get an answer for the PV system, actually you can use this 1,100 volt divided by the panels open circuit voltage. You can get value, and minus 2 or 3 or 4 depends on your local lowest weather condition. So as you can quickly get an answer. Here is an application, and if you are using a Longi 550 watt PV module and SAJ inverter, here you will use the formula on last slide. You can get the first is lower should under the range of 19.73, and the formula 2 you can get a range. Then you will get the suggested one string panels range from 4 to 19. Then I would like to introduce the swing voltage will have the impact on the inverters working. When greater than the MPPT range will you can see the see here it will have a sharply decreasing of the inverter working, and if your voltage is not enough for the full load MPPT voltage range, it still cannot meet to hit the 100% output. So as you can see here, it's a channel from other inverter manufacturer. So only under this range, like 500 to 850, you can get the full load range. At last, if you are choosing the PV panel capacity depends on how large your rooftop is. But if you would like to install an energy storage system, the battery is also difficult to determine. You should take your usage data, the return of investment, and future to use, and load condition and backup service time. You are going to need a lot of things need to take into account. For example, if you have a 5 kilowatt solar power plant on your rooftop, average 4 hours equivalent power generation, 800 ampere hour battery you are going to take. Due to maximum charging current is 100 ampere, and the backup mode, the battery will need 2 days for fully charged. But and the self-using mode, it will take about 13 days to fully charge if 3 kilowatt hour generation for 4 hours per day for battery charging per day is gonna waste of battery investment. And you should also take in the battery efficiency into account. And that's all for today's sharing.